Hello everyone. Today's video is about the profit cost revenue function. We kind of zipped through the notes in class, so I thought I'd make a video just so that we are on the same page. If you need to slow down, rewind, pause, any of that good stuff, you have that opportunity now. So we're going to start off with the two examples that we did in the notes, and then after that we're going to fast forward into our homework assignment. So find the formula for the revenue function if the price demand function of a product is, it's given to us, where X is the number of items sold and the price is in dollars. So in order to write that price demand function, or in order to write the revenue function, we're going to have to look at our price demand. So it's given to us right here. If we are trying to figure out revenue, I'm going to use R as my revenue function. That means I take my price demand and I'm going to have to multiply it by X because X is the number of items sold. So for us here, our price demand function is the 54 minus 3x. If I multiply that expression by x, I get 54x minus 3x squared. So that right there is my revenue function. From there, I could plug that into the y equals of my calculator, and I can use that to answer the questions that were posed. So considering I do want to find the maximum, the question's asking me all about max revenue. I know that when I plug the function into my y equals, I'm going to be trying to calculate my maximum. And I see those points given to me here, the x and the y value. I just need to translate and figure out which part answers which question. So how many items should be sold in order to maximize the revenue? Well, our x represents the number of items. So that if I bring that down here and I round it, I'm not selling 8.9 items, I'm selling 9 items. I know that's going to maximize my revenue at $243. All right, so X is my number of items sold, and Y is my max revenue when I have given my profit function and I have to write my revenue function. So not too bad, right? In the next example in the notes, we went a step further. We said, all right, well, I'm not going to give you the price demand function this time. I need you to calculate it. So I do give you the hint that the price demand function is always going to be linear. So, and I give you two pieces of information or two data points. I tell you that when an item is $40, then we sell 150 of them. If I'm going to choose to write that as a coordinate, I know it's 150, comma 40. Think about your independent and your dependent variable. The second piece of information I give you is that now when the price is raised by $5, so our price is $45, we're actually going to be selling only 100 of these items. So regardless of how we choose to write our equation from here, and we'll talk about the difference between our slope-intercept form, which is up here, slope-intercept form and point-slope form. We'll talk about both of those in a minute and the difference between them. Regardless, we need to figure out our slope. So I give you the slope formula here. I give you that little Algebra 1 reminder that slope is a change in y over the change in x. So I'm just going to take those two data points that I have here, plug that into my slope formula. So y equals, or m equals y2 minus y1 over x2 minus x1. I solve, and I'm going to get 5 over negative 50, which is going to give me negative 1 over 10 when I simplify it. So some people swear by slope-intercept form. They think that that's the easier one to use here. If that is what you're comfortable with, go ahead and use it. I'm just a fan of the lesser-known formula, the point-slope guy right here, because I think it's easier to plug into. We already knew what our x1 and our y1 values were. It's the same x1 and y1 that we had used in our equation over here. So, and honestly, it doesn't matter which one that you use. You can use either the first coordinate or the second coordinate. You just have to pick one. So for the sake of argument, I'm just going to use the first one. I'm going to plug those values in appropriately for the x1 and the y1. I'm going to plug in the m, the slope that I just found out. And then always keep the y and the x in the equation. So separate this out. I have y minus 40 equals -1/10 times x minus 150. Okay. So from here, we do have to convert it in order to figure out what our revenue function is. So to convert this into the slope-intercept form, I do have to distribute into the parentheses. And then solve from y. So I get that y is equal to -1/10x plus 55. So this right here is actually my price demand equation. So when we're asked to find our price demand equation, that's this guy right here, price demand. So from the prior example, we learned that once we know our price demand equation, we just have to multiply it by x, and that gives us our revenue function. So we'll do that in our next step to answer part B. So our revenue function, we'll call it R, is going to be equal to my P from the prior multiplied by X. So you can go ahead and leave it as is. That's actually what I did when I plugged this into my calculator. Or you can choose to distribute if you'd like. Either one is totally fine. Once it's plugged into our y equals, again, we're looking to maximize our revenue. So that means we're looking for our maximum or our vertex. So again, in the interest of time, I had plugged this all into the calculator already and calculated our maximum. All we have to do is translate from here. So find the number of items sold that will give us our max revenue, and what is that max revenue? So similar to last example, I'm going to have to round this to 275 items. So 275 items will maximize our revenue at, it looks like $7,562.50. Okay, so 275 items sold will maximize our revenue at $7,562.50. So let's go a step further now. I'm going to go a little bit more in depth into this problem than we did in the prior one. We want to know what's the price at which each item when maximum value is achieved. So, okay, well, we know what our price demand function was. That was the blue one from up above. So if we take that same function, but we can plug in the 275 items, x plus 55. So if we plug that in, we will be able to get our final answer there of what our price should be. So if we simplify this, we get, looks like $27.50. So our little sweet spot for this item, whatever that they're selling here, our sweet spot, we want to be able to list the price for $27.50. That way we're going to maximize our profit. Because we know at that price point, we're going to be able to sell 275 items. So again, let's go a step further. If the company finds a fixed cost of $3,520 and a variable cost of $12 per item, we have to find the company's linear cost function. So I'm going to call cost C. We're told that we have a variable cost of $12 and a fixed cost of $35.50. We know this cost function is going to be linear. So think about, again, your slope-intercept form, y equals mx plus b. M is your variable cost, and your fixed cost is your b. Okay. In the next example, we need to find the company's profit function. So profit is equal to our revenue subtract our cost. Okay, wrote that over here. Our profit is equal to our revenue subtract our cost. So our revenue, if you remember correctly from up above, our revenue, let me get rid of this so I have space. Our revenue was at -110, 1/10 x squared plus 55x. So that was our revenue. If I subtract my cost from that, my cost was the prior step, 12x plus 3520. If I simplify all this, it looks like I'm running out of space. I should get the -1/10 x squared plus 43x minus 3520. And that gives me my company's profit function. So next step, we want to find the number of items sold that give the maximum profit. So I'd gone ahead and plugged that profit function into my calculator. And again, I'm looking to maximize profit. So I calculated my vertex, my maximum. Then it's just a matter of translating what it means. So my maximum is located at 215, 1102.5. So 215 represents the number of items sold. So we have to sell 215 items. To maximize profit at the 1102.50. So how many items should be sold for the company to break even? So break even, we're not making any money. Our profit is 0. So that means we're looking here along our x-axis. And we actually have 2 points of intersection here. We have a 0 here and we have a 0 over here. So we're going to have to calculate each one of those zeros separately since we have actually 2 possible answers to this question. So how many items should the company sell in order to break even? They could sell 110 items, or they can actually sell 320 items to break even. If either of those happen, they're doing all right. They're breaking even. All right, so that concludes our notes from the other day. Now we had our homework examples. So in these examples, I've given you a lot of the information. I'm just asking you to find a piece. So here we're talking about a gymnastics clothing manufacturer, and they're distributing hockey jerseys. All right, I'm giving you the cost function here for the specific domain where X, the number of hockey jerseys, is between 0 and 150. That's a restriction upon our domain. So we just have to keep that in the back of our minds as we're going through and we're answering this question. The bookstore is able to sell the jerseys for $90 each. Well, then our revenue is determined when we multiply the cost for the jerseys by X, the number of jerseys that we sell. So that's it. That's our revenue. Our profit function from before, so profit is equal to revenue subtract cost. So our profit is going to be equal to our revenue function from our prior step, so 90x, minus cost, which was given to us way up here. So make sure that when we're doing this out, we distribute the negative to all 3 terms that are here, 0.2x squared. All right, when I combine like terms, when I distribute that negative, I get negative 0.2x squared plus 80x minus 1500. So that is our profit function. Next point, now we want to be able to, now that we have a profit function, we have profit, we have cost, we have revenue, we have everything that we need, we want to be able to answer some questions. So how many jerseys then should this clothing manufacturer make to make a profit? So let's take a look. Here it looks like, again, we have 2 zeros, similar to the last problem. We have a 0 that's located over to the left of the function, and we have another one over to the right. So again, we have 2 possible answers, or seemingly so. But we said keep in the back of your mind as we're going through and we're answering the questions here that we have a restriction on our domain. This clothing manufacturer, for whatever reason, can only make up to 150 jerseys. They literally can't do anymore. So for this answer here of 380, it's outside of our domain of possibilities. So we have to cross it out. The only viable answer for us is this 19.72, which I can round that to about 20 jerseys. Because we have our profit, right? If this is our function, literally anything, this was our break-even point. So anything above that, this is all considered profit. Right. In the next example, here again, I'm asking you to do a little bit more work. I'm giving you two separate data points, and we're going to have to use those data points in order to be able to answer the question. So a popular designer makes purses. They sell for $500 and 45,000 units are sold each month. The company did some research and realized that for every $20 decrease in price, they will sell 5,000 more units. So we're looking at really two different things here when we're talking about revenue. We're talking about the price for the item, and we're talking about the number of items that are sold. So this is similar to before in our example when we were trying to come up with our revenue function. So our revenue is going to be our price, so I'll call that P, multiplied again by X, which is going to be our number of items sold. So let's think about this. Our number of purses sold. Well, we know that we could sell 45,000 purses. We know that. We sell 45,000 purses. And we can actually increase, so plus, increase our number of sales by 5,000 for every $20 decrease. So I'm going to have X here, where X for me is going to represent my number of $20 decreases. My pen does not want to write. I'm sorry. My number of $20 decreases. From there, we could look at our price, and we could write a separate function for that. How much easier. All right. So let's talk about our price now. So we know that our price initially can start out at $500. So we know we have $500, but we know that we're talking about $20 decreases. So we need to subtract from this $20 by the number of decreases that we have. So this here will give us our revenue function. If we plug our revenue function into our calculators, and again, I don't even bother distributing here, I plug it in, you see it with the parentheses, and I looked at my maximum. So based off of the graph here, how many purses should the company charge so that they can maximize their monthly revenue? Well, we know that if we have 8, remember here my X represents not my number of purses, but my number of $20 decreases. So I had to decrease my price. I started at 500. I had to decrease it 8 times by $20. So I had to take my 500 and subtract 160 from that. So that means that that's $340. So how much should the company charge for the purses to maximize their revenue? If they can charge $340, that's going to be their sweet spot. They're going to be able to maximize their revenue. I think that's 2.8 million, if I'm looking at the number of zeros right, dollars in revenue per month, right? So hopefully that was a little bit better. You're able to pause Let me know if you have any questions. And as always, thank you so much for watching.